I'm Nusra. Today in this video, we are going to study about the states of matter. And here I have given the definition for matter and energy. So a matter is anything that occupies a space and has a mass. And energy is the right opposite of matter, which does not have a mass or does not occupy a space. For an example, if we are thinking about a piece of paper, it does occupy a space and it has a mass. So it belongs to the category of matter. Or a glass of water, the water. If you're thinking about the water, it occupies a space and it has a mass, so it is a matter. But if we are thinking about the sunlight, which does not have any mass or does not occupy space, so sunlight is a form of energy. And the sound energy. So the sound energy does not occupy a space and does not have mass, so for sure sound energy is a form of energy. So the entire universe is made up of either a matter or energy. So the entire universe is made up of either a matter or energy. So whatsoever around us, if you are thinking about anything around us, it will be a matter or energy, nothing other than these two. Okay, let's move ahead and see more about matter. States of matter. So matter can be further divided into three more categories depending on the phases of matter. So for an example, the classical states of matter will be solid, liquid, and gas. So a matter can be in any of these three forms. It can be a liquid, it can be a gas, or else it can be a solid. And here I have given some pictures, some examples for solid. So it can be a pen, a stone, a ball, or any living organisms, including human, are matter, and especially that comes under the category of solid. And of course, when we are speaking about a complex living organism, it has, the entire body can be compared to a solid. But if you're thinking about the blood that runs around a living organism, that will be a liquid. And if we are thinking about the respiratory system, the gas that we are inhaling and exhaling will be something that belongs to the category of gas. And here I have given some examples for liquid. It's water or fresh juice or milk, maybe, as I said in the previous slide, blood, petrol, and gas. So oxygen, carbon dioxide, and the LPG gas, that is liquid petroleum gas in the gas cylinders that we're using for the cooking purposes. So it's an example again for gas, liquid petroleum gas. Okay, now we are going to look about the particles arrangement of a solid. This picture over here shows the particles arrangement. The microscopic picture shows over here the particles arrangement of a solid. So we can see over here that these particles are tightly packed and they do follow a regular pattern. And these particles keep on vibrating. They do not move, but they keep on vibrating, and we can observe a regular pattern. So particles in a solid do not flow easily. It's because they are tightly packed. So they do not flow easily. Moreover, they cannot be easily compressed. And yes, it has a fixed volume and a shape. Since it has this regular pattern, the shape of a solid is fixed. Moving ahead, we have the particles arrangement of liquid, and we can see over here that the particles in a liquid are close together, but with no regular arrangement like in the particles of solid. So we can see the pattern, the arrangement is not regular, it's randomly arranged. And the shape of the part of the container which it occupies. So if we are thinking about the shape of a liquid, it does not have a fixed shape. And if I'm pouring some water into a glass, the water takes the shape of this glass. And if this water is transferred into a bowl, it takes up the shape of the bowl. So it does not have a fixed shape, and it takes up the shape of the container that it belongs to. And it is not easily compressible like solids, but unlike solids, they do flow easily because of their irregular arrangement. So liquid can flow easily. And here we have the particles arrangement in a gas, and you can see over here, particles in a gas are well separated. They have enough space so that they will be moving randomly, and the movement is having a really high speed and no regular arrangement, so they do flow easily, and it's compressible. We can easily compress the gas particles since we have a huge amount of space left, and the shape and the volume of its container, that is like liquids, gas also occupy, or gas also take up the shape of the container, and the volume can be changed. The volume of the gas can be changed according to the volume of the container that it exists in. Okay, and from here onwards, we are studying about the changes in the state of matter. So as we said, we have three states that are solid, liquid, and gas. We can convert these matters from one form to another, from one state to another. For example, if we are turning solid into liquid, this process is known as melting, and melting is done when we are increasing the temperature. So when the temperature is increasing, obviously, the solid starts melting and it forms liquid. So melting is when a solid changes into liquid and it requires heat energy, that is temperature has to be increased. And then it occurs at a particular temperature only. For example, the ice cube in our refrigerator will be in, let's say, negative 10 degrees Celsius. So if I'm increasing the temperature to negative 5 degrees Celsius, I cannot expect this ice cube to be melted. Rather, if I am increasing more to negative 2 degrees Celsius, still this ice cube will be an ice cube, that is, it will still maintain the solid state. But if I am reaching 0 degrees Celsius, this is where the solid starts melting. So this specific temperature is known as melting point, and melting point is the temperature in which a solid will start turning into a liquid. So for each and every substance, maybe for water, or maybe it can be milk. So for each and every substances, we have specific melting point, and the melting point of water will be 0 degrees Celsius. Evaporation is again the state change from liquid to gas. And it still has to happen when the temperature increases, and the specific temperature on which a liquid turns into gas is known as the boiling point. And this speaks about sublimation, which is a bit uncommon. So sublimation is a solid turning into gas directly without forming liquid. So it is not melting, it is sublimation, because a solid turns into a gas, and this is really uncommon, happens only in few solids like iodine, naphthalene, likewise. And freezing is the opposite of melting. So freezing is liquid turning into solid, and freezing for water, the freezing point of water is 0 degrees Celsius. So the melting point and the freezing point is the same. It's because at that temperature, at this temperature, if we are exceeding this temperature, the solid will turn into a liquid. If we are moving this side, if we are reducing the temperature, the liquid will become a solid. So freezing is when a liquid changes into a solid, and this is the reverse process of melting. And melting point and freezing point of pure substance are the same, and for water it's 0 degrees Celsius, as we discussed already. Condensation is the process of gas turning into a liquid. So liquid to gas was evaporation, and gas to liquid, which is the right opposite operation of evaporation, is known as condensation. And for condensation to take place, the temperature has to decrease. So at lower temperature, this process will be taking place. All right. So now we are going to get a summary on the changes of states. So when we have a solid, and let's say we have liquid and gas. So the state change from solid to liquid is melting, and liquid to gas is, of course, it is evaporation, and solid to, okay, gas to solid. Let's not speak about that for now, which we are going to speak within a couple of minutes. And the opposite operation, liquid to solid, it is freezing. And gas to liquid, of course, condensation. And solid to gas, sublimation. And gas to solid, which is again rare and uncommon, is desublimation. So this is sublimation. This is desublimation. Gas to liquid is condensation. Liquid to gas is evaporation. Solid to liquid, melting. Liquid to solid, freezing. So this is a pictorial summary of the state's changes of matter. And we have to know that for these process to take place, we should reach a particular specific temperature which differs from substance to substance. For an example, for melting to happen, we have to exceed melting point. For freezing to happen, we have to exceed freezing point. So for each and every process, we have a specific temperature defined for specific substances under the other constant environmental conditions. That's it for today.